So here's my table that I filled in when doing this activity. And the original triangle, my intention was for it to be a 3, 4, 5 triangle with those values as its exact side lengths. But I know my initial triangle wasn't perfect. So if your measurements, your initial measurements or your measurements of the larger side lengths of the larger triangles, if your measurements were different than mine, that's really okay. So you're supposed to look at the table and just see what you noticed about it. And I hope you noticed, and I hope you got similar results, and noticed that the ratios that you calculated, the ratios of those different side lengths, were pretty consistent. And it makes sense that those ratios would be consistent as we move through the triangles from smallest to biggest, because the triangles were, in fact, similar triangles. And a pretty loose definition of similar is just same shape but different size. And that's really what we see here in these triangles. And again, it makes sense that they'd be similar due to the fact that the initial triangle contained angle A in the given triangle. And then as you constructed the larger triangles, angle A was still one of the angles of the triangles. So all three triangles had angle A. Additionally, all three triangles had the right angle. So in your small triangle you had the right angle, in your medium triangle you had the right angle, and in your large triangle you had the right angle. And that really is enough to show and really to prove that the triangles are similar. And so since the triangles were similar, it does make sense that these ratios of the side lengths would be consistent. So if we look at this first ratio, A over B, so side A is the side that's opposite angle A, and then side B is the hypotenuse of the right triangle. If we take a look just at that visually, A over B, that ratio, it makes sense that the ratio A over B in the small triangle would be the same as the ratio of A over B in the medium triangle and A over B in the largest triangle. And it's because these triangles are similar. So when we have this situation, when we have this fixed angle, and when we're working inside of right triangles, the ratio of these sort of internal side lengths is going to be consistent no matter how big the triangle you draw, as long as it maintains that initial angle and is also a right triangle. And because of this consistency with the ratios, we have a whole field of study around these ratios called trigonometry, and these ratios are special and they're called trigonometric ratios. And really, these three ratios I had you calculate have some other names. The A over ratio B, of A over B, we actually would again call was the side opposite angle A, and B was the hypotenuse. Opposite over hypotenuse, that ratio is called sine. The ratio C over B, which was the side adjacent to angle A, over the hypotenuse, that's called cosine. And finally, the ratio of the side across or opposite angle A over the side adjacent to angle A, opposite over adjacent, is called tangent. So since these ratios are consistent every time we draw that similar triangle, that's why they have special names, and that's why we study them.